today's video session. I remain Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss oxidation numbers. We shall continue our discussion on oxidation numbers. This will be part 2. As we please, before you continue with this video, it is recommended that you view part 1. Very important. In this part 2, we shall solve more problems, and we shall go into oxidation, reduction, oxidizing agent, reducing agent, and the rest of them. So it is important that you view part 1 first before you view part 2. You can get the notes and the link to the video, videos, as well as other resources on this website, chemical-reaction.appspot.com. chemical-reaction.appspot.com. You can also go to my website directly, www.samuelchukwuemeka.com or www.chukwuemekasamuel.com, any one of them. So we're going to solve more problems. I have several questions here, and we will just do them and we explain them. The previous video we did nitrogen 1 oxide, we did nitrogen 2 oxide, we did nitrogen 4 oxide, and then we did nitrogen 5 oxide. That was what we did in the previous video. So in this video we shall continue from that. Question 5. Question 5. We are asked to find chromium in K2Cr2O7. Find the oxidation number of chromium. So if we separate it, K2Cr2O7, let the oxidation number of chromium be X. Let it be X. Now potassium, we know that the oxidation number of potassium is +1. Okay, we discussed that in part 1 of the video. Then chromium, we just put X here. I'm going to use yellow chalk to write this. And then oxygen, we know that it is -2. So this will be 2 times 1 plus 2 times X plus 7 times -2 equal to 0. The entire is 0. So we have that 2 times 1 is 2 plus 2 times X is 2X minus 14 equal to 0. So 2X minus 12 is 0. 2X is 12, so X is 6. X is +6. +6. So if we were to name this IUPAC nomenclature, this will be potassium heptaoxo dichromate 6. Potassium heptaoxo dichromate 6. Okay? And then, like we said in the previous video, I might not write everything down because it is going to be in the notes here. So you can write down, you can pause the video, but the notes, what I am explaining, that even though if I do not write it, it is in this, it is in the website. Okay. All right. Question 6. We asked to find nitrogen in zinc nitrate. Nitrogen in zinc nitrate. Nitrogen in zinc nitrate. Zinc nitrate is the old name. Please forgive me, I will be saying old names, but I'll be saying the common names. But what I really want you to learn is the IUPAC name. So I will say, if I say zinc nitrate, that's because I learned it with the common names. That's when I learned chemistry years back. So, I am certified in chemistry, you know that, right? So to teach chemistry, I am. So, if I use common name, that's fine, but I will also say the IUPAC name, because some professors are now specific that they want IUPAC name. They want it. So actually you need to know IUPAC name. Now when you're gonna go to medical school, if you're studying medicine or nursing, I wouldn't be surprised that some of them are still using market names and common names. Okay, market names and common names. Alright, so let's spread this out. We have zinc, and we have this NO3 and then 2. So we have zinc. Zinc is 30. I think we probably did this problem. I think we have done this problem in part 1 as an example when I was explaining. So zinc is +2. Okay, we've done this one of the explanations I did. Then let the oxidation number of nitrogen be X. Be X. Oxygen is -2. So we have that 2 plus this 2 is for nitrogen and it is also for oxygen. So this is 2 times X. 2 times X plus 2 times 3 times -2. This 2 here is for nitrogen and also for oxygen. So 2 times this 3, oxygen, then times -2, equal to 0. Equal to 0. So we have that 2 plus 2x, 2 times 3 is 6. 6 times minus -2 is -12, equal to 0. So 2x minus 10 is 0. 2x is 10. So x is +5. +5. So what is the IUPAC name for this compound? It is zinc trioxo nitrate 5. Zinc trioxonitrate 5. Okay. Question 7. Let's have more space for this. Question 7. We are asked to find the oxidation number of boron. Boron in sodium boron, hydrogen. Sodium borohydride. Now, let's do this. We spread it out. We have sodium, we have boron, we have hydrogen. Sodium, from the part 1 video, this is +1. It is an alkali metal. And let the oxidation number of boron be X. Then hydrogen, now this is a metal hydride. And from what we talked about in part 1, for metal hydrides, the oxidation number of hydrogen is +1, except for metal hydrides when it is -1. This is -1. So we now have 1 plus X plus 4, this 4 times -1 equal to 0. So this is 1 plus X minus 4 equal to 0. So X minus 4, X minus 3, 1 minus 4 is -3. So X minus 3 is 0, X is equal to +3. So what is the IUPAC name for this? This will give us sodium tetrahydro, okay, 4 hydrogen atoms. Sodium tetrahydroborate, borate 3. Sodium tetrahydroborate 3. Okay? Sodium tetrahydroborate 3. Question 8. It's making sense, right? It's making sense. Question 8, we have KBr, potassium bromide. Potassium bromide. And then I want to explain something. I want to explain something here. Question 8 and then question 9 here. Question 9. Potassium bromate. So before I just said the common names. This is potassium bromide. This is potassium bromate. Bromate. So do you see how KBr, potassium and bromine, potassium bromide. Excuse me. If we have KCl, this is potassium chloride. But when we have KClO3, this is potassium chlorate. Chlorate. Do you see the I and the 8? Ide. If you see that 8 you see here is because of the oxygen, the A. Potassium chlorate. Potassium bromate. That 8 you see at the ending is because of the oxygen involved. But if this is potassium bromide, this is potassium bromate. So just, by the time you deal more with compounds, you see what I mean with the common names. Potassium bromide, potassium bromate. Okay, we're asked to find the oxidation number of bromine. Bromine here. Oxidation number of bromine. Bromine in potassium bromide. And then bromine in potassium bromate. Bromine in potassium bromate. Okay, here, let's write it out. Potassium and bromine. Potassium, of course, we know is +1. Bromine, let it be X. X. So, we just have that 1 plus X is 0, X is -1. That is this. And this is just potassium bromide. Okay, potassium bromide. Potassium bromide is used as an anticonvulsant. It's used to treat epilepsy in dogs. Potassium bromide, it is used as an anticonvulsant. Potassium bromate. Potassium bromate is used in baking. They use it in baking to enhance the flour, the flour in baking, flour, to make the dough to rise, It's used to enhance the flour and to make the dough to rise. Now, it's used in baking, but it is a banned product in Europe. Europe banned it because this is a very dangerous substance. And I hope I don't get in trouble in this video. Okay, see why I'm saying this. See why I'm saying it. I have no idea why America has not banned potassium bromate in making bread. I have no idea. Europe has banned it. Even Nigeria, can you imagine? Nigeria has banned something. So Nigeria even values life. I didn't know Nigeria values life. I didn't know. So for Nigeria to even, I hope I don't get in trouble in this. Of course, you're not gonna get in trouble. See, I didn't know Nigeria values life. I did not. So, but Nigeria, for even Nigeria to ban it, what does that say? What does that say? And America has not banned it. America has not banned it. Now this, as some scientists have made some research and found that this substance is carcinogenic in rats. It causes cancer in rats. So if it causes cancer in rats, why don't you just ban it? Why? You know, you want to maybe let Congress pass so that they ban potassium bromate. And you see lobbies. You see lobbies. Special interest groups. No, because they are making money from it. We want the bread to rise. So if you're buying bread and eating here, make sure you're always praying to God. If you're buying bread and eating, make sure you're always praying to God. Because some companies still use it. Some don't use it, but some use it. It is a bad product. Bad substance. Europe has banned it. Even Nigeria has also banned it. Now, why has America not banned it? Why? I have no idea. It's the same thing, this thing. They were doing a world, it's a meeting. It's a meeting of several countries of the world. They were meeting to promote natural breast milk. They want to adopt that for countries to promote natural breast milk to feed babies. And America said no. Why would America say? You can never compare artificial formula to breast milk. Never. How can you compare artificial things to natural things? It's not possible. You can't compare it. You cannot. You cannot compare artificial things to natural things. You don't want to promote breast milk. But you know that breast milk is far more nutritious to the health of the child. And you want, because the companies making a formula, you don't want them to lose market, to lose profit. You don't want to promote breast milk. So what you see, this life, you want to bring somebody in this world. You want the best for the person. You bring somebody in this world, care for the person. Make the person healthy. Give the person every good thing. Raise the person to love one another and be healthy and praise God. You know, so that's the thing anyway. But this is not a good product. I am not. Nobody paid me to. Nobody does not. I'm not paid to speak against any product or so. I'm just a scientist. I'm a mathematician. I'm a scientist. So I'm just saying the truth. Okay. So let's go ahead and find this. We write it out. Potassium bromate. The oxidation number of potassium is +1. Let the oxidation number of bromine be X. And then of course that of oxygen is -2. So we now have that 1 plus X plus 3 times -2 is equal to 0. Okay? So 1 plus X minus 6 is 0. So we now see that X minus 5 is 0. So X is +5. So the IUPAC nomenclature for this is potassium trioxobromate, bromate 5. Potassium trioxobromate 5. That is the IUPAC name. All right, question 10. Question 10. Is this making sense so far? Do you understand it? Una otaraya comprender? Comprenez-vous? Una otaraya. Question 10, we have gold, aureum. Gold is aureum. Or is from the Latin name aureum, gold, aureum. Gold in sodium, gold, chlorine, this is a hydrate. You know what I mean by hydrate? Some people will say water. When you talk about water of crystallization, this is a hydrate. Because of, you see, 2 water. Some people will say 2 water. But some people will say dihydrate. Or some people will say 2 water. 2 is di. So please, in part 1 we talked about all these prefixes. We talked about it in part 1. So 2 is di, so I will say dihydrate. Some people will say 2 water. Okay, let's go ahead because we want to find gold in this. We are not going to do, the dihydrate is not, we're not putting it, no. We're not putting the dihydrate, we are doing this, okay? So we write it out, sodium, gold, chlorine. The oxidation number of sodium is +1. Let the oxidation number of gold be X. And then the oxidation number of chlorine is -1. So this will be 1 plus X plus 4 times -1 equal to 0. So 1 plus x minus 4 is 0. X minus 3 is 0. So x will be plus 3. So this will be, this is, let us say the IUPAC name for it. This is sodium tetrachloro, orate 3, sodium tetrachloro, orate 3, dihydrate. Some people might say 2 water, but I prefer dihydrate. Sodium tetrachloro 4 chlorine. Sodium tetrachloro, orate 3, dihydrate. Okay, question 11. So let me get a pen so that anything we do, we tick it off. So we've done all this here. We've done this now. The next one here, question 11. We have carbon in carbon, oxygen, chlorine. So carbon. So we write it out. Carbon, we want carbon, so let the oxidation number of carbon be X. Oxygen is -2, chlorine is -1. Okay? So we have X minus 2 plus 2 times -1 equal to 0. So X minus 2 is 0, X minus 4 is 0, X is equal to plus 4. Okay? X is equal to plus 4. So this is a carbonyl dichloride. Carbonyl dichloride. Question 12. Phosphorus in phosphate ion. Phosphate ion. Phosphorus in phosphate ion. Phosphate ion is the common name. Okay, so let's spread it out. Now remember what we said, that this is an ion, and in part 1 of this video we said that the oxidation number, because oxidation number of the compound is 0, but the oxidation number of this ion is the charge, is the ionic charge, the charge on the ion. Okay, it is a cathode ion, a cation, cathode ion. So let the oxidation number of phosphorus be X. That of oxygen is -2. So So this will give us that x plus 3 times minus 2 is equal to minus 3. Okay? And this will give us that x, because this is equal to minus 3, the charge on the ion. So x minus 6 is equal to minus 3. X is minus 3 plus 6. X is plus 3. X is plus 3. So this will give you, if we name this IUPAC nomenclature, this will be trioxo phosphate from phosphorus, phosphate 3, trioxophosphate 3 ion, trioxophosphate 3 ion, trioxophosphate 3 ion. Okay? Question 13. Question 13. Question 13, we have C carbon in metanoic acid. Metanoic methanol or methyl alcohol. This is not metanoic acid. Metanoic acid is HCOOH. This is a methanol. Your methanol. Metanoic acid. Sorry, why did I keep saying metanoic acid? Alkanoic acids. Alkanoic acids is COOH group. But alcohols actually is alkanols. Okay, aka alcohols. But alkanols is the OH. Alkanols. So this is your methanol, that's your wood spirit. Your methylated, Nigeria will say methylated spirit. Methylated spirit. This is methanol or methyl alcohol. Then if it's ethanol, ethanol is 2 carbon atoms. Ethanol. That is your ethanol is actually your alcohol. The ethanol, you also use it in your gas. America, they mix ethanol with petrol, and they tell you it's mixed. So this is your alcohol, ethanol. Then this is your methanol or methyl alcohol. Methyl alcohol is like old name. So this is organic chemistry. Okay, so it's methanol. That's what we call it, methanol. That's the IUPAC name. Is methanol. So we now find the oxidation number of carbon in methanol. So let's separate it. Okay. You can also write this as CH4O if you want to. Okay, but you know the OH is a group for alkanols. Alkanols have OH functional groups. So let the oxidation number of carbon in methanol be X. Hydrogen is +1. This is not a metal hydride, no. Oxygen is -2, hydrogen is +1. So this will give us X plus 3 times 1, then plus minus 2 plus 1 equal to 0. So x plus 3 minus 2 plus 1 equal to 0. So x, 3 minus 2 is 1, 1 plus 1 is 2. So x plus 2 is 0. So x is minus 2. And this is your methanol. Methanol. Okay. Yeah, when you do organic chemistry, you come to naming compounds according to IUPAC nomenclature. Question 14. Like I said, we have a lot of questions tonight. A lot of questions tonight. We have oxygen in K2O2. Okay? So we have potassium and then we have oxygen. Of course, the oxidation number of potassium here is plus 1. And then oxygen, let's call it X. So this is 2 times 1 plus 2 times X equal to 0. So 2 plus 2X is 0. 2X is minus 2. X is minus 1. Oxygen. Remember one of the rules we said in part 1 of the video is that oxygen has an oxidation number of minus 2 except in peroxides or if it is bonded with fluorine. We talked about that in part 1. So this is a potassium peroxide. Potassium peroxide. Potassium peroxide. Potassium peroxide. Potassium peroxide. Okay? Next one says question 15. It says here, the oxidation number of copper. It says the oxidation number of copper, the oxidation number of copper is from dash to dash. So we are beginning because we need to, like I said, we're going to introduce you because after this video we will now do balancing redox reactions. So it's important. We're now coming, gradually to that. The oxidation number of copper is from dash to dash. In this reaction, you have copper sulfide, copper 2 sulfide, solid. This is a solid. Let me write it here. It tells you the state of the substance. S is solid, L is liquid, solid, liquid, and gas. G is gas, and then AQ is aqueous solution, aqueous. So solid copper sulfide reacts with oxygen gas to give you copper, 2 moles of copper, 2 moles of solid copper, and sulfur 4 oxide. Please, I would like you to I would like you to, by the time you solve more problems, you can easily look at a question and name it right away. Like I know this is copper 2 sulfide. Oxygen gas reacts with oxygen gas to give you solid copper 2 sulfide, reacts with oxygen gas to give you solid copper, 2 moles of solid copper, and 1 mole of sulfur 4 oxide. You asked me, how do I know sulfur oxide? Okay, I know chemistry, but if you find out, if you take the sulfur 4, because this is x minus 4 equal to 0, you say let the oxidation number of sulfur be x, then you see x minus 4 equal to 0. One thing about chemistry is this: you've got to solve a lot of problems. When you solve a lot of problems, then you know it. Like I look at redox reaction now, I know which one is oxidized, which one is reduced. I know the oxidation numbers. And you know, I want you, by the time you solve a lot, you just look at any compound and you name it. You can name it. Okay? So that is what I really want you to learn. That's what I want you to learn. So, but they're asking us just for copper. As you can see here, did I say copper 2? Copper 2. You see, this is not copper 2 sulfide. I'm sorry. No, this is copper 1. Copper 1 sulfide. This is copper 1 sulfide. Okay? Copper 1 sulfide. I'm sorry. That's copper 1 sulfide. Copper 2 sulfide is just CuS. Okay? So this is copper 1 sulfide to give you just solid copper 0. So this is plus 1 to 0. You know, that's the answer. Plus 1 to 0. I'm sorry, I said copper. Copper 2 sulfide is just CuS. So look at what we do, folks. This is copper 1 sulfide. Let the oxidation number of copper be x. Sulfur is minus 2. The oxidation number of sulfur is minus 2. Okay? So this will be, this is minus 2. So this is 2x minus 2 is 0, 2x is 1, 2x is 2, so x is plus 1. And of course, for this copper here, it is just 0. Yeah, don't worry about the 2, this means 2 moles. This is 1 mole of copper 1 sulfide reacts with 1 mole of oxygen gas. 1 mole of solid copper 1 sulfide reacts with 1 mole of oxygen gas to give you 2 moles of copper, 2 moles of solid copper, and 1 mole of gaseous sulfur 4 oxide. That is what it means. So when we do the mole concept, stoichiometry, you have to watch out for that video. We solve a lot of problems, it's not difficult. Stoichiometry, yeah, it's not difficult. So, you know, I thank God for talent. Thank God. So this is from plus 1 to 0. That's the change, from plus 1 to 0. Okay, question 16 is next. Question 16. Another way you can tell this, even without solving this, let me teach you a trick. Like, you know, you have copper, you have sulfur. This is 2. Copper actually is plus 2. So if it's copper 2 sulfide, you just CuS because the 2 will cancel. You know, when you have Cu2S2, then 2 cancels 2. So you have CuS. Okay, but because you have Cu2S, that means that this is 1. So, because actually you do it like this in naming compounds. In naming compounds, you do it like this. So this will be Cu2S1, which is just Cu2S, copper 1. Copper 1. Okay, or you can just solve it like this. But I want you, you know, with time, you just look at it and you know what is what. Okay, question 16. Here we have, this question says, state the oxidation states of each element. Okay, state the oxidation states of each element. Each one, they want you to state each one, each of the elements, state the oxidation states. I think that's what they did here. Yeah. Oxidation states of each element. But before we do this one, let's do this particular one here. V10 vanadium O28 6 minus. Vanadium, okay, and then oxygen. So vanadium in this, vanadium in this, vanadium in this ion. This is also a cathode. This is an anode ion, anion. Anode ion, anion. What did I name the other one? The other one is the PO3 3 minus. Did I say it was cation? No, it's an anode ion. Anode ion, anion. Okay? I probably said this was this PO3 3 minus. This is an anode ion, anion. They are the negatively charged ions. They go towards the anode, the positively charged electrode, while the cations go towards the cations go towards the cathode, the negatively charged electrode. Okay? That's the positively charged ions are the cathode ions, because they go to the cathode in electrolysis. The negatively charged ions are the anode ions, because they drift to the anode. Okay? So this is an anion. This is an anion too. I'm sorry if I said cation, I'm sorry. It's an anion. Anion. Anode ions. Because they move to the anode, the positively charged electrode. Okay, the negatively charged ions move to the positively charged electrodes. So they are the anode ions or the anions. The negatively charged ions, the positively charged ions move to the negatively charged electrode or the cathode. And that's why they are called cathode ions or the cations. So these negatively charged ions move to the anode. So they are the anode ions. Okay? So my bad if I said cation, is anion. Alright? I'm a human being, I make mistakes, I'm sorry. But I corrected myself, right? I corrected myself. Alright, so let V10O28 6 minus. Only God does not make mistake. Human being, we make mistake. We always make mistake. But make mistake, correct yourself. So let the oxidation number of vanadium be X. Let it be X. Oxygen is minus 2. So, I want to use yellow chalk. So this is 10 times X plus 28 times minus 2 equal to minus 6. Equal to the ionic charge, the charge on the ion. So this is 10x minus 56 is equal to minus 6. 10x is minus 6 plus 56. So 10x is 50 X is plus 5. X is plus 5. So, IUPAC name for this will be Deca 10 vanadate. Deca vanadium. Deca vanadate 5 ion. Deca vanadate 5 ion. Some people will say, why don't you name this then oxo, right? Please go with this. This is easier, deca vanadate, than coming up to find 28. What's the prefix for 28? And then you put oxo, vanadium 5. So go with this, deca vanadate 5 ion. Question 17. Question 17. It says here, find the oxidation states of each element. So we have A, B, C, 1, 2, 3, 4, 1, 2, 3, 4, D, E, F. So question 17 has a lot of kids. It has several kids. So they want you to find oxidation state of each element. Okay, we do it and then we name it. So we have the calcium carbide. This is explosive. Calcium carbide, barium oxide, barium peroxide actually, barium peroxide, because of 2 oxygen atoms. This is barium oxide. This is barium oxide. But this is barium peroxide. Barium peroxide. Europium. Europium is from Europe. Europium bromide. Gallium hydroxide. Gallium hydroxide. Dioxonitrate ion. And then selenium sulfide. Selenium sulfide. So they want you to write the oxidation states of each of these. Of each of them. So and then we name it. I think I've already named it anyway. Let's go ahead and do that. Calcium we already know is plus 2. So I'm going to come here, I'll write calcium is plus 2. So with that, 2, we already know calcium is plus 2. Okay? So with that, so let this be x. And 2 plus 2x. So this is plus 2. Calcium carbide, this is plus 2. And this is x. So we have that 2 plus 2x, 2 times x is 0. 2 plus 2x is 0. 2x is minus 2, x is minus 1. So here, carbon here is minus 1. Okay? Barium is plus 2. Barium is plus 2. Remember, barium is group 2 element in the periodic table. We discussed this in part 1. Group 2 elements are the alkaline earth metals. They are always plus 2. Their oxidation numbers are always plus 2. Always plus 2. So, calcium is there, barium is there. Now, for barium oxide, what did I say barium oxide? I'm sorry. Barium oxide is just BaO because it's 2,2 and it will cross out. 2 will cancel 2. Okay, this is barium oxide. Barium oxide, 2,2. I have Ba2O2, 2 crosses out, so I have BaO. That's barium oxide. Yeah, but this is barium peroxide. You have 2 oxygen atoms joined by a single bond. So you have +2 here, and this is X. Call this X. Call this X. Okay? So this is barium peroxide. So this 2 + 2X. In peroxides, oxygen is in peroxides, the oxidation number of oxygen is -1. We talked about that in part 1 of the video. So oxygen here is -1. Okay? Europium. It is an element named after Europe. Europium 3 bromide. Bromine is -1. So you have Europium 3 bromide. Okay? Bromine is -1 except when it's joined with fluorine. When it is bonded with fluorine. So this is if you want, this is X, and this is -1. So you have X plus 3 times -1 equal to 0. X minus 3 is 0. X is +3. So this is a Europium 3 bromide or Europium bromide. So Europium is +3, bromine is -1. Gallium, let's find out of gallium hydroxide. Gallium hydroxide. So with gallium, you have OH3 here. So let the oxidation number of gallium be X. Oxygen is -2, hydrogen is +1. Okay? So this is X plus 3 times, this 3 is for oxygen, which I've written, then times -2, then plus 3 for hydrogen times 1 equal to 0. So this is X minus 6 plus 3 equal to 0. So X minus 3 is 0. X is equal to +3. So this is gallium 3 hydroxide. Gallium 3 hydroxide. Calcium carbide, calcium 2 carbide, if you want to say that. Or just say calcium carbide. When you have two, compounds, that's fine, except if it has multiple oxidation states, Calcium, we already know, is always going to be 2. So calcium carbide. Now this one is barium peroxide. If you're naming it IUPAC nomenclature. Then C, Europium 3 bromide. Europium 3 bromide, IUPAC nomenclature. 4, and this, like I said, check out here. So I don't, as I'm explaining, you can write or you just check the notes here. This one, D, is gallium 3. Gallium 3 hydroxide. Gallium 3 hydroxide. Then E, dinitrogen what? Ion. This is an anion. This is an anode ion. An anion. So let nitrogen be X. Oxygen we know is -2. So this is X plus 2 times -2 equal to -1. X plus 2 times -2 equal to -1. So this is X minus 4 equal to -1. So this is X equal to -1 plus 4. X equal to +3. So this is a dioxonitrate 3 ion. Dioxonitrate 3 ion. Dioxonitrate 3 ion. Okay? Selenium. Selenium and sulfur. Let the oxidation number of selenium be X. Sulfur we know is -2. So this is X plus 2 times -2 equal to 0. X minus 4 is 0. X is plus 4. So this is selenium 4 sulfide. Selenium 4 sulfide. If it has multiple oxidation states, it is better, much more recommended. It is recommended that you say the oxidation number. Okay? Like, because if you have carbon now, for instance, you have CO, you have CO2. You can't call both of them carbon oxide. No. No, because carbon has multiple oxidation states here. So you have to call it, just like the example we did in part 1, where we have nitrogen 1 oxide, nitrogen 2 oxide, nitrogen 4 oxide, and nitrogen 5 oxide. You cannot just say nitrogen oxide, no. So if it has multiple oxidation states, you've got to put the oxidation number in the name. Carbon 2 oxide, carbon monoxide, that is what you inhale from cigarettes. If you smoke cigarettes, you're inhaling carbon monoxide, and from the exhaust fumes of cars and buses, carbon monoxide, very dangerous to health, very, very dangerous. I mean, this can kill someone. This carbon monoxide, it can kill somebody. You inhale some amount, a substantial amount of it, you die, because it can kill someone, carbon monoxide. So that's what causes, it's one of the pollutants. It's a very big air pollutant, carbon monoxide. So, when people say put generator, you go to Nigeria, and okay, what's the electricity problem? Generator. That is very, very wrong. That's very wrong. And you have to blame the Nigerian government that Nigeria has not even 1 year. I'm asking for 1 year. I am asking for 1 year of uninterrupted power supply. Dream in Nigeria. Dream. It's a dream. Pipe dream. What is called a pipe dream. In fact, let me not call it a dream, because some dreams happen. I don't believe in dreams anyway, but some dreams happen. Okay, let me call it a shadow. Somebody chasing his shadow. And that is very unfortunate, because Nigerians, we have a lot of intellectuals. We have a lot of intellectuals. So they say you go to Nigeria, the problem is generator. When I hear that word generator, I am very angry. Very, very angry. Why are you putting generator? Because number 1, air pollution. Number 2, noise pollution. Hey! No. See, it's the problem. The government is ineffective. Ineffective government that cannot work. They cannot work. Because it cannot solve the problem of electricity. And I know why I'm truth, I just hope and pray I don't get in trouble. Okay, so this is a very poisonous gas. Dangerous. And it's from the generator, from cars. It's very dangerous. This is carbon 4. This is carbon 2 oxide. This is carbon 4 oxide. We call this carbon 2 oxide. Common name is carbon monoxide. Mono is 1. Remember we said in part 1 video, mono is 1. Di is 2. Carbon dioxide. But that is common names. IUPAC name is carbon 4. Carbon 4 oxide. Carbon 2 oxide. Nitrogen 1 oxide. Nitrogen 2 oxide. Nitrogen 4 oxide. Nitrogen 5 oxide. Now look at this one here. SO3, SO2, SO3. SO2, sulfur 4 oxide. Now what about this one? Sulfur 6 oxide. Sulfur 6 oxide. So when you have a compound with multiple oxidation states, you have to put the oxidation number there. You have to put it there. Okay, question 18. So before we do question 18, let us now talk about some new terms. We're going to talk about some new terms. Let us talk about some new terms. Oxidation. Reduction. Oxidized. Reduced. Oxidizing agent. Reducing agent. Okay. So I don't want you to memorize this. I will try to teach you this so that you will grasp it well. Let's start with reduced. When somebody said he has been reduced to nothing, you know, reduction, reduced. You had $5 yesterday, and now you have $2. There's a reduction. It's been reduced. Your money has been reduced. You had $2 yesterday, and today you have $5. Your money has been oxidized. Now, reduced, we talk about, you know, electrons, movement of electrons. Who accepts electrons? Who donates? Who donates electrons, and who accepts electrons? Remember, we talked when we discussed oxidation numbers in part 1. We said oxidation number is the number of electrons that are being either given or accepted. Okay, so when we have chemical reactions, redox reactions in particular, and there is a transfer of electrons, okay, we are talking about, okay, when we talk about the transfer of electrons, somebody gives it out and somebody takes it. The giver and the receiver, okay, the donator and the acceptor. Who donates and who accepts? Who gives and who receives? So we are looking at who gives and who receives. I want to explain this in a way that you will not have to memorize it. So So we look at donate, who donates and who accepts. Who gives, or who gives and who receives. Who loses and who gains. These are just the synonyms with it. It's just the synonyms with it. There is a transfer of electrons. That is in redox reactions. Okay? Reduction oxidation reactions. There is a transfer of electrons. And when there is a transfer of electrons, that means it is transferred from the giver to the receiver. Somebody gives the electrons. Somebody receives the electrons. Somebody donates the electrons. Somebody accepts the electrons. Somebody loses the electrons. Somebody gains the electrons. In marriage, you know what I'm talking about. The man gives, the woman receives. Okay, so as a man, I said it's a marriage. I said it's a marriage, right? So now let's now remove human being. Let's come to chemistry. Electrons are negatively charged. Electrons are negatively charged. Electrons are negatively charged. Okay? So when you get a negative, you're reduced. If you get a negative, you receive a negative, you're reduced. Whenever you receive a negative, we don't want negatives, we want positives. But if you ever receive, electrons are negatively charged. So if you accept a negative, you become reduced, period. So whoever accepts electrons are reduced. And whoever gives the electrons out are oxidized. Okay, I'm not going to write everything because I want you can read the notes. I want you to just understand where I'm going. So, electrons are negatively charged, so whoever accepts it will become reduced. Whoever accepts it will become reduced. Whoever gains it, whoever receives it will become reduced. But whoever gives it, whoever donates it, whoever loses it, let me lose all this negativism from my life. You know, sometimes when you're filled with, you have a lot of negative guys. You know, sometimes a woman or a man anyway might say, I need to get rid of all these negative people in my life. Like, get rid of them, it means I need to like stop hanging out with them so I can breathe fresh air. Problem we have in Nigeria, fresh air. Okay, so back so when you lose electrons, you become oxidized. You are not reduced. Okay, whenever you lose those electrons, lose, you become oxidized. Okay, oxidation, loss of electrons, lose. And then when you now take in the negatives, see, some people were, you know, sometimes bad friends corrupt good morals, right? Bad friends corrupt good morals. Sometimes, so you have bad friends, corrupts good morals, and you become reduced. You've gained bad friends. Gain of electrons. So does it make sense at all? Do you kind of understand where I'm coming from? Because you don't need to memorize all these. You need to understand it. Understanding is different from memorization. Okay? So, now, look at the trick here. An oxidizing agent is the agent that will accept electrons to become reduced. A reducing agent is the agent that will lose the electrons to become oxidized. So that is the trick now that I really want you to understand. An oxidizing agent, okay, an oxidizing agent will cause the other person to be oxidized because it's an agent. And by causing the other guy to be oxidized, he or she becomes reduced. A reducing agent will cause the other guy to be oxidized. It's an agent, okay? An agent will cause, an oxidizing agent will cause the other. When you come in contact with an oxidizing agent, that agent will cause you to be oxidized. And by being oxidized, he or she becomes reduced. Because oxidation and reduction cannot occur in isolation. They must occur in unison. They must occur together. They have to occur together. They cannot occur in isolation. You cannot give away electrons for somebody not to receive. No way. And you cannot receive electrons unless somebody gives it to you. Okay, so because I want you, if you understand these concepts, then balancing redox reactions will be easy for us. Okay, balancing redox reactions will be very easy for us. But I want you to really understand that concept. Okay, losing negatives out. Lose it. I want to lose all those negatives out. That's good. I'm no more reduced. But when you take negatives in, hey, negatives are not good. They make you reduced. So reduction is gain of electrons. You gain it and you are reduced. That's reduction, reduced. But you lose the electrons, lose the negatives out. I'm free. I'm oxidized, charged. Okay. So just know that oxidizing agent will cause the other. You come with an agent. So when you're dealing with agents, when you're dealing with an agent, okay, you don't want to deal with an agent. So an oxidizing agent will cause the other guy to be oxidized, and by so will be reduced. So oxidizing agent, okay, is reduced because it will cause the other guy to be oxidized, and by so doing will be reduced. Reducing agent will cause the other guy to be reduced, and therefore is oxidized. Is oxidized. So reducing agent is oxidized. Oxidizing agent is reduced. The agent. So I want you to understand that. Understand it. In the questions we're going to do, the rest of the questions we're going to do, for the questions we'll do now, they want us to identify the substance that is oxidized. That's number one. Number two, that is reduced. Number three, the oxidizing agent. Number four, the reducing agent. That is what they want. They want us to identify the substance that is oxidized, that is reduced, that is the oxidizing agent, and that is the reducing agent. So please, it's important you understand this, because once you can grasp this, balancing redox reactions is not going to be a problem for now. Okay? So Let's get it started, folks. So the next question will be question 18. Okay, and for the questions that we're gonna do 1, 2, 3, 4, 5, 6, 7, 8. For the next 8 questions, that is what they want us to do. Identify the substance that is oxidized, that is reduced, that is the oxidizing agent, that is the reducing agent. So, question 18, we have cobalt. 1 mole of cobalt and plus 2 moles of hydrogen bromide. Hydrobromic acid to give you cobalt 2 bromide. Now, by now I'm thinking that you should, know that this is cobalt 2 bromide, because bromine is -1. So X plus 2 times -1 is equal to 0. So X minus 2 is 0. Okay? Or you just know, okay, cobalt, bromine. So this is 1, this is 2. So this goes here, this goes here. So this is cobalt 2 bromide. Okay? I expect you to know this by now. Okay? Cobalt 2 bromide plus hydrogen. We are starting with the simple ones. Okay? Alright, now we're going to write, and they also say the next one is neither. If we have neither, we also state. Okay? So identify is 5 questions. 5 sub-questions. A, identify the substance that is oxidized. B, identify the substance that is reduced. C, identify the oxidizing agent. D, identify the reducing agent. And then E, identify the substance that is neither oxidized nor reduced. Okay. We're gonna say here, we're gonna write here, let oxidizing agent, let's just state oxidizing agent as OA. So if you see me write OA, let the oxidizing agent, remember it's an agent, it's always going to be reduced because it will make the other guy oxidized. So it's going to be reduced. Okay? Let the oxidizing agent be OA. And then let the reducing agent be RA. Okay? RA. All right. Oxidized. Neither. And then reduced. So let's look at the oxidation numbers. Because how do we know all this? We know this by oxidation numbers. If we have an increase in the oxidation number, from reactant to product, that means that substance was oxidized. If we have a decrease in oxidation number from reactant to product, that means that substance was reduced. Remember what I said, if you had $5 yesterday, today you have $2, you've been reduced. If you had $2 yesterday, today you have $5, you've been oxidized. Alright, so alright. as you can see here, cobalt is 0, because if you look at this here, this is 0. This is 0, and this is +2, cobalt 2. This is +2. 0 to 2. 0 to 2. Okay, so if you see here, oxidized cobalt is the substance that was oxidized. Why? Because of the increase in the oxidation number from 0 to +2. It was increased. Does that make sense? So, as you can see, it was oxidized because it increased in oxidation number. Now, reduced hydrogen bromide. Hydrogen here is +1. Don't worry about the 2 moles. No, we are not concerned about the 2 moles. No, we are concerned about the formula of the substance. Okay? So hydrogen is +1 here, and hydrogen is 0 here. So as you can see, hydrogen, okay, hydrogen is the substance that was reduced because it's 1 + 1 to 0. +1 to 0. You see that? And then bromine, neither. Because bromine here is -1. And bromine here is still -1. Bromine there is still -1. You see that? So neither is bromine. Okay? Just write the atom of the element. And this is from -1 to -1. It was neither oxidized nor reduced. And then, of course, because cobalt was oxidized, cobalt is the reducing agent, is cobalt. Cobalt is the reducing agent. Of course, metals are good reducing agents. But I don't want you to memorize it. Later we'll come and do the electro activity series. But I just want you to understand this here. Remember, a reducing agent is always oxidized, and an oxidizing agent is always reduced because it's an agent. Okay, you come in contact with it, it makes you oxidize, thereby it becomes reduced. So reducing agent is always oxidized, and the oxidizing agent, okay, in this case, is the hydrogen bromide. Hydrogen bromide. Please do not write hydrogen, no. This is an agent. So it's not like in the one that was oxidized or reduced, I know it is the element, the atoms, the atom. But when you're writing the agent, write the actual substance. That this is the reducing agent and this is the oxidizing agent. Hydrogen bromide. Hydrobromic acid. Okay? Does that make sense? Does it make sense? Got it? Okay? Question 19. We have the zinc. This is zinc reacting with chromium 3 ion to give zinc 2 ion. This is a cation, a cathode ion. This is a cathode ion, cation. Plus chromium. Okay? And then here, this is actually, we're not talking about, we don't want to talk about balancing for now. They just wrote this as I got this question. Okay, they just wrote it and asked the question. So we're going to just do that. So here, zinc, so we're not talking about balancing for now, no. This is not balanced at all. It's not balanced. Okay, it's a redox reaction. Redox reaction is any reaction that you have oxidation and reduction. It is what we are doing now are redox reactions. So in this case, I just saw this question, I got it from somewhere, and I know it's not balanced, but for now, we're not worried about balancing. Let's just find what they asked us to find, okay? Now, oxidized, neither, and then reduced. So, this is zinc here is 0, okay, 0. This is 0, and this is plus 2. From 0 to plus 2. And then chromium is from plus 3 to 0. So as you can see, zinc is oxidized. Zinc, because it's from 0 to plus 2. So zinc is the reducing agent. Zinc is the reducing agent. So zinc is the reducing agent. And then we don't have anything that is neither oxidized nor reduced, no. So neither, just leave it. Now reduced is chromium. Chromium 3 ion. Chromium, just write the atom, okay? Just write the atom. Chromium, and this is from plus 3 to 0. It's reduced, okay? So it is the oxidizing agent. It is the oxidizing agent. So the oxidizing agent, reducing agent here is zinc. Zinc. Oxidizing agent here is the chromium 3. Please write it as chromium 3. Don't write only chromium atom, no. The reducing agent here is the zinc, because it is oxidized. And the oxidizing agent here is the chromium 3 ion. Chromium 3 ion. Okay? It is not chromium atom, no. Do you see the difference? Do you see what I'm saying? Do you understand? Do you understand what I mean? Okay? Here, oxidizing agent is hydrogen bromide. It is not hydrogen, no. It's hydrogen bromide. Okay? Question 20. Is this making sense so far? Is it? 20, question 20. We are getting there. We have magnesium, solid magnesium, reaction of solid magnesium and nickel chloride, aqueous nickel chloride, to give magnesium chloride, aqueous, and nickel solid, solid nickel. So, oxidized, neither, reduced. So here, magnesium is from 0. Okay, 0 to magnesium 2 chloride. I mean, that's because chlorine is -1. Okay, chlorine is -1, so x plus 2 times -1 equal to 0. So x minus 2 is 0, x equal to 2. 0 to 2. And then magnesium chloride. You don't really need to say magnesium 2 chloride. Magnesium is always going to be +2 anyway. Okay, but if it has variable oxidation states, then you need to. If you want to say magnesium 2 chloride, that's okay. Nobody is going to penalize you for it. Okay, but we know that the oxidation number of group 2 elements are always +2. Okay, so that's fine. So magnesium is oxidized. Magnesium is oxidized because it is from 0 to +2. And then the reducing agent, as we have here, is this magnesium. Okay? Now, chlorine, nothing happens to chlorine. Okay, chlorine here is -1, chlorine here is -1. Nothing happens to it. So chlorine is neither, chlorine is neither from -1 to -1. Neither. And then reduced is nickel. Nickel here is +2. Nickel here is +2. And then nickel here is 0. From +2, nickel is reduced from +2 to 0. Now, what is the oxidizing agent? Oxidizing agent is not nickel. No. It is nickel chloride. Nickel chloride. Nickel 2 chloride. Nickel 2 chloride. That's the oxidizing agent. Do not write nickel. No. Okay? Nickel is the substance that is reduced. So the oxidizing agent is nickel 2 chloride, while the magnesium is the substance that is oxidized. The reducing agent is magnesium. Okay? Question 21. Question 21. We have an ionic reaction here. It's an ionic reaction and also a redox reaction. So we have magnesium, solid magnesium react with hydrogen ion, 2 moles of aqueous hydrogen ion, and 2 moles of chloride ions, aqueous chloride ions, to give magnesium ion, aqueous magnesium ion, plus 2 moles of chloride ions, aqueous, plus hydrogen gas. Let me write this here so you can see it well. Let me write it here, okay? Let me write it here so you can see it. So we have magnesium solid magnesium, plus 2 moles of hydrogen ion, aqueous hydrogen ions, plus 2 moles of chloride ions, to give magnesium ion, magnesium 2 ion, aqueous, of course it's going to be aqueous anyway, plus 2 moles of chloride ions, aqueous of course, and then hydrogen gas, 1 mole of hydrogen gas. 1 mole of hydrogen gas. So here, oxidized, we know that this is magnesium, this is 0 to +2. To +2. Hydrogen is here is +1. Please don't worry about the moles. Don't worry about the moles, no. Only the element is what we're interested. So this is +1 to 0. To 0. And of course chlorine, this is -1 to -1. Okay. So oxidized is magnesium. Magnesium was oxidized, okay, from 0 to +2. Reducing agent is the magnesium. Magnesium is reducing agent. Solid magnesium is reducing agent. Neither is the chloride ion. So we're gonna put chlorine from -1 to -1. It was neither oxidized nor reduced. Then hydrogen, just be putting the atoms only. We'll just be putting the atoms. So neither here is the chlorine atom. Okay, this is the magnesium atom. And then the reduced is the hydrogen atom. Just put the atom. From +1 it was reduced to 0. From +1 to 0. Now the oxidizing agent here, okay, is the hydrogen ion. The hydrogen ion is the oxidizing agent. Like I said, don't worry about the moles. No, don't worry about the moles. Okay? Does it make sense? Okay, question. Now this was question 22. This was question 22. So the next one will be question 23. Question 23. We have phosphorus 3 chloride, phosphorus 3 liquid phosphorus 3 chloride plus chlorine gas to give us phosphorus 5 chloride solid. Okay, so oxidized neither reduced. Okay, so this phosphorus 3, don't just say phosphorus chloride. Phosphorus has variable oxidation states. So this here is phosphorus is +3, chlorine is -1. Chlorine gas here is 0. Chlorine gas here is 0. Phosphorus here is +5, and chlorine is -1. Okay. Now from 3 to 5, from +3 to +5. So phosphorus is oxidized from +3 to +5. And what is the reducing agent? Reducing agent is the phosphorus 3 chloride. Phosphorus 3 chloride. Reducing agent is always oxidized. Okay? Because you come in contact with it, it will reduce you, therefore becoming oxidized. It's an agent. Okay. Then reduced is the chlorine gas. Okay, chlorine is reduced from what? From 0 to -1. To -1. Chlorine is reduced from 0 to -1. So what is the oxidizing agent? The oxidizing agent is the chlorine gas. That's the chlorine gas. Then neither will be the chlorine from here. The chlorine from this phosphorus 3 chloride. Nothing happened to it. Okay, so the chlorine from phosphorus 3 chloride is neither, because it is from -1 to -1. It's from -1 to -1. The chlorine from here. The one that was reduced is this chlorine here. The chlorine gas. That's the one that was reduced. Therefore, it's the oxidizing agent. The chlorine from this guy was neither oxidized nor reduced. Okay? The next one, question 24. Question 24. question 24. We have 24, 25, 26, 27. Okay. We have here 3 moles of solid copper. Yeah, this one is too long, so we'll do it here. We'll do this one here. Okay? We'll do this one here. So let's look at short ones. Okay, we have, this is ethane gas, ethane, combustion of ethane. 1 mole of ethane gas reacts with 3 moles of oxygen to give us 2 moles of carbon 4 oxide, 2 moles of carbon 4 oxide plus 2 moles of steam, 2 moles of steam, water vapor. So this is a gaseous reaction. Everything is gases. The reactants are gases, the products are gases. It's a gaseous reaction. We have oxidized, neither, and then reduced. So here, this is ethane, alkenes. When you do organic chemistry, alkenes have the general molecular formula H2, HCN, CHC, CnH2n. So C, 2H4, C3H6, that's your propene. C4H8, that's your butene. Pentane is C5H10. So this is your ethane. This is your ethane. Ethane, when you burn ethane gas, okay, this is a combustion reaction. Combustion of this is a hydrocarbon. The hydrocarbon, when the combustion of hydrocarbons gives you carbon 4 oxide and steam. Okay, you do that in organic chemistry. The alkanes, the alkynes, and the alkynes. So this is ethane to give you carbon 4 oxide and water. Okay. Here, hydrogen is +1. This is not a metal hydride. So hydrogen is +1. And if hydrogen is, of course, oxygen here is 0. Just don't worry about the moles. Like I said, don't worry about the moles. Just focus on the formula. So this is O2. Oxygen is 0. Now, let's find the oxidation number of carbon. Oxidation number of carbon in ethane. So you have C2H4, this is X, this is +1. X, and this is +1. So you have 2X, 2 times X, plus 4 times 1 equal to 0. So 2X equal plus 4 is 0. 2X is minus 4, X is minus 2. So this is minus 2 here, minus 2. Now this is carbon 4 oxide. Carbon 4, this is +4 here. Oxygen, of course, is minus 2 here. Then hydrogen, water, of course. This is O is -2 and H is +1. Okay? The water. Hydrogen is +1, O is -2. Okay, so let's now find out who is who. Now, oxidized, if you look at carbon, -2 to +4, that's an increase. Okay? So, its carbon is oxidized from -2 to +4. And what is the reducing agent is the ethane. The reducing agent is the ethene. Ethene. That is the reducing agent. Oxygen is reduced from 0 to -2. That's reduction, reduced. So oxygen is reduced from 0 to -2. So oxygen reduced from 0 to -2. So the oxidizing agent is oxygen. Is the oxidizing agent. Okay? Like I said, forget about the moles. Forget about the moles. Then neither your hydrogen is +1 here, and it's also +1 here. So hydrogen is neither oxidized nor reduced. It is from +1 to +1. See that? Do you understand it? Okay. Question 25. Question 25. You see, this is not, it's not difficult, right? Is it? Is it difficult? No, it is not difficult. Is it difficult? No, it is not. Question 25. We have 3 moles of solid copper. 3 moles of solid copper. Reacting with the heptaoxodichromate 6 ion. Heptaoxodichromate 6 ion. I think we have done this example, right? Heptaoxodichromate 6 ion. We've done the example, and it is also in my notes there. Aqueous, of course, is ionic. Then plus 4 moles of aqueous hydrogen ion to give you 14 moles, 14 moles of hydrogen ion to give you 3 moles of copper 2. 3 moles of copper 2 ion plus 2 moles of chromium 3 ion. 2 moles of chromium 3 ion. And 7 moles of water, liquid water. 7 moles of liquid water. Okay, copper here is 0. Copper here is 0. And copper here is +2, copper 2. Chromium here is +6. Because this is heptaoxodichromate 6 ion. We have done this. I think we did. We did it. Heptaoxodichromate 6 ion. Heptaoxodichromate 6 ion. So x, 2x, 2 times x, or 7 times -2 equal to -2. Because this is x, and this is -2. So this is 2x minus 14 equal to -2. 2x is -2 plus 14. So 2x is 12. And x is +6. Okay? Heptaoxodichromate 6. Heptaoxodichromate 6 ion. So chromium 3 ion, and hydrogen here of course is +1. Hydrogen here is +1 also. Oxygen here is -2, and oxygen in water is -2. Okay, so who was oxidized? That is from 0 to +2. Okay, copper was oxidized because it was oxidized from 0 to +2. What is the reducing agent? The reducing agent is the copper. Is the reducing agent. Reduced was chromium. Chromium atom from +6 to +3. From +6 to +3. Okay? That's reduction. And who is the oxidizing agent? Oh, these are strong oxidizing agents. Chromium. This is a heptaoxodichromate 6 ion. Potassium chromate. That's the common name. Potassium heptaoxodichromate 6. Very strong oxidizing agent. Very strong. Another one is potassium permanganate. Potassium tetraoxomanganate 7. Okay? Please calm down. You will learn this, okay? Don't worry. Don't worry. Okay. And see, so I taught chemistry in Nigeria before I came to the US. I came to the US, I taught chemistry for only 1 year, But I still have my teaching certificate in chemistry. I'm still certified. I taught it for only 1 year. But then I look at my folks back in Nigeria and they're struggling with chemistry. Why? So, this is for everybody. Nigerians, Americans, Africans, everybody. It's not difficult. It's not. And if I have the time, I will do more problems, topics that folks find difficult. Solubility, electrolysis, calculation of electrolysis calculations, and just having the time. So, okay, so this is the oxidizing agent. It is the oxidizing agent. Neither, as we can see here, oxygen was neither, because it's from -2 to -2, and then hydrogen is neither, because it's from +1 to +1. Okay? Right? Okay. Question 26. Question 26. We have here 3 moles of solid copper reacting with 8 moles of nitric acid. Now, this is a nitric acid. That is a strong acid. It's very corrosive. Trioxonitrate 5 acid. This is a trioxonitrate 5 acid. Is a strong acid. Like, it's very corrosive. If you touch it on the skin, it burns the skin. So when you're taking students to the lab, these are you want to keep these out from children. From students. You have to really, really supervise them. This is very corrosive. The same thing with hydrochloric acid, HCl, and the tetraoxosulfate 6 acid, H2SO4. So, 3 moles of copper reacting with 8 moles of trioxonitrate 5 acid. If you calculate the oxidation number of nitrogen, it's going to be 5. Okay? To give you, and don't worry, we can calculate it. To give you copper nitrate, 3 moles of copper nitrate, aqueous, and 2 moles of nitrogen 2 oxide gas, 2 moles of gaseous nitrogen 2 oxide. Like, I want you to be able to look at this and be saying the names. Okay? Plus 4 moles of liquid water. 4 moles of liquid water. Okay. So copper we know here is 0. We know that, right? And here, of course, we know copper is 2. It's copper nitrate. But if you want to, we can calculate it. It doesn't matter. So you say it. When you do radicals, when you do radicals, you can see copper and then nitrate. Copper is 2 here, this is 1. So this here, this here. So copper nitrate. But let's say you don't know what is radicals. That's fine. That's okay. Don't worry. Okay, let's just calculate it. Let's do copper here. So you have copper, you have nitrogen, oxygen 3, and then 2. So copper, let it be X. No, copper is 2, I mean. Copper is 2 plus 2. Nitrogen, let it be X. Oxygen, let it be minus 2. Okay? So you have here 2 plus 2 times X plus 2 times 3 times minus 2 equal to 0. So 2 plus 2x, 2 times 3 is 6 times minus 2 is minus 12 equal to 0. So 2x minus 10 is equal to 0. 2x is 10. So this means that x is 5. X is plus 5. So this is still copper nitrate. And if you do that of hydrogen, the nitric acid is the common name. Trioxonitrate 5 acid. Trioxonitrate 5. Trioxonitrate 5. So hydrogen is plus 1, N is X, O is minus 2. So this is 1 plus X plus 3 times minus 2. 1 plus X plus 3 times minus 2 equal to 0. Okay? So 1 plus X minus 6 is 0. X minus 5 is 0. So X is plus 5. Okay? X is plus 5. So you see here, hydrogen is plus 1, N is plus 5, O is minus 2. Okay? Copper here is plus 2, nitrogen is plus 5, O is minus 2. And here, nitrogen 2, this is nitrogen 2 oxide. Nitrogen 2 oxide. Nitrogen is plus 2 here, O is minus 2. Okay? And if you want to spread this out, that's fine. I hope you understand what I'm doing. Then water, H is plus 1 and O is minus 2. Okay, folks, who was oxidized from copper 0 to 2, copper 2? So copper was oxidized from 0 to plus 2. So the reducing agent is copper. Copper is the reducing agent. Then nitrogen is from 5. This nitrogen here, nitrogen 5. Nitrogen is from plus 5 to plus 2. You're not talking about this nitrogen also, no. This nitrogen reduced from 5 to 2. So reduced is nitrogen from plus 5 to plus 2. Okay? And the oxidizing agent is the nitric acid. That's the oxidizing agent. Okay? Then neither is hydrogen and oxygen. Hydrogen from plus 1 to plus 1, and then oxygen from minus 2 to minus 2. Those are neither. Does it make sense? Alright, folks. Last but not the least. Question 27. Last but not the least. Question 27. 27. Last but not least. We have zinc, solid zinc. 1 mole of solid zinc reacts with tetraoxosulfate 6 acid. 1 mole of tetraoxosulfate 6 acid to give us zinc sulfate. Zinc tetraoxosulfate 6 aqueous and hydrogen gas. 1 mole of hydrogen gas. Okay? This is another strong acid here. Tetraoxosulfate. Tetraoxo 4 oxygen. Sulfate 6. If we do the oxidation number, you will see that it's sulfate 6. So we are looking at oxidized, neither, and then reduced. Zinc here is 0, and zinc here is 2. Is zinc 2. Okay, is zinc 2 plus 2. Now, this is sulfate 6. If we do this here, H2SO4. H is plus 1. This is X, this is minus 2. So this will be 2 times 1 plus X plus 4 times minus 2 equal to 0. So this is 2 plus X minus 8 equal to 0. See that? This is X minus 6 equal to 0. So X is plus 6. The same thing if you have it here, zinc sulfate. I mean, the common name is zinc sulfate, but the IUPAC name is zinc tetraoxosulfate 6. Okay, zinc is plus 2. This is X, this is minus 2. So as you can see here is the same thing, 2 plus X plus 4 times minus 2 equal to 0. 2 plus X minus 8 is 0. X minus 6 is 0. So X is plus 6. Okay? So here we have hydrogen is still plus 1. Sulfur here is plus 6. Oxygen is minus 2. Zinc is plus 2. Sulfur is plus 6. Oxygen is minus 2. Hydrogen here is 0. Hydrogen is 0. So folks, we are almost done with this. So oxidized would be from 0 to plus 2. Zinc. Zinc is oxidized from 0 to plus 2. The reducing agent is zinc. Reducing agent is the zinc. Hydrogen is reduced. Hydrogen is reduced from plus 1 to 0. Reduced. The oxidizing agent is the tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. Okay? Okay, so some people will say hydrogen tetraoxosulfate 6. Okay. When we do acids, bases, and salts, you will see that acids readily ionize in water to form hydrogen ions or hydrozonium ions. Okay. So if you call it hydrogen tetraoxosulfate 6, that's okay. But when we do acids, bases, and salts, we have to call it tetraoxosulfate 6 acid. Alright, then the neither will be sulfur. Sulfur is from +6 to +6. Okay? And also oxygen. Oxygen is from -2 to -2. Okay. There are more questions. However, there are just a few more questions I have here, but it's some are multiple choice as well. But I would prefer, when I have the time, I'll type it here. At least you have a good grasp of this. This video is getting long, so let's stop here for tonight. The remaining questions are just few. But let's stop here for tonight. Just later look at the solved examples and also exercises that you can attempt. Go to this website and solve more problems. Okay? Alright. Thank you so much for listening to this video session. If you have any questions, please feel free to contact me. When you contact me, please, when you contact me, you have to be patient. You have to be positive. You have to be patient. So when people contact me, I look at the email. If it's a negative thing, I don't respond. I don't have time for that. I am a very busy man. Very busy. So please, when you contact me, if you want me to respond to you, you have to be positive and you have to be patient. Okay? I want you to succeed, The joy of a teacher is what? The success of his students. Thank you for listening to this presentation. If you have any questions, please ask. And you have a great